I think Google really hates me. You can join now. Good. Oh, Krisha, that's a pretty cool drawing. Did you draw that? It's kind of violent, though. What is that? That's what I thought. It's a little on the violent side. I'm not going to judge you, though, but just make sure I'm always on your good side. Okay. Andre, hair looks good. It's okay. I still say my symbol, or my, what do you call those? Forgot what we call them. Anyways, my UFO symbol's the best. No? Okay. So, page 207. List the name of the reactant. So the reactants are on the left side, right? Or on the right side? Good. Left side. Because they react to give you the products. So the reactants are hydrogen and nitrogen. If you want to be more precise, hydrogen gas, nitrogen gas. At room temperature, I'm assuming they are gases. To produce, it doesn't ask you for the products, but the product is ammonia. Give the formula of the product, NH3. Okay, so just so you're aware, and ammonia is what you find in a lot of your cleaning agents, stuff that you use in your bathroom or kitchen. Three, how many molecules of hydrogen will combine with one molecule of nitrogen? So that's why you've got the coefficients in front. So the numbers in front, that's a coefficient. There's no number in front of the nitrogen. That implies there's a 1 there. So the coefficients are 3 and 1, 3 for the hydrogen. 3 molecules of hydrogen combined with 1 molecule of nitrogen. That's what the coefficient means. To produce what? You need 3 of the hydrogen and 1 of the nitrogen to produce 2 of the NH3. It's kind of like a recipe. You don't follow the recipe, you don't add enough hydrogen, you're not going to get the product. You need 3 for every 1 to produce 2. Okay, is this being recorded? Can you hear me? Yeah, good. 4, how many molecules of nitrogen are required to produce 10 molecules of ammonia? Okay, so instead of 2, we want to produce 10. Okay, now you want to produce 10. So you'd have to obviously up the ingredients, increase the ingredients. By a factor of what? 5. Whatever you do on the right, you do on the left. 5. 5. So you need 15 of the hydrogen and 5 of the nitrogen. to produce 10 of the ammonia. Okay. 5. What is the symbol that means produces? That's it. Arrow. Produces, to make. Fancy word that means creates or makes. Okay, what does it produce? It produces the product. That's a general term of whatever you get. The product can be 2 or more compounds. Well, it could be 1 or more compounds, actually. You see in this case, we get 1 compound of ammonia. Could be more. Okay, practice problems at the bottom. List the total number of each. So let me write it down here. Number 1. Again, this is all page 207. 2H2O. I would memorize this. This is water. We use it over and over again. Plus 2 sodium fluoride. Okay, list the total number of each atoms in the following. So what's the rule? That's called a coefficient. That's a coefficient. You multiply the coefficient by, this is called a subscript. Multiply the coefficient by the subscript. Bigger number by the smaller number. For each element. For H and for O. For Na and for F. You could think of this as, although we don't write it this way, you could think of it all being in brackets. We don't do that. You don't need to. As long as you make the number big, that's your hint. It's a big number. That means you multiply everything to the right of it. All the small numbers to the right of it. So that means 2 times 2, 4 hydrogen. 2 times 1. There's a 1 here, even though it's not shown. 2 oxygen. What about here? 2 times 1. Because there's no number there, it means 1. That means 2 sodium. Again, go back to the number in front because you have to multiply each element by the coefficient. 2 times 1. Okay? And that's it. You just make sure there's not a doubling up. There may be sometimes another O here. You have to add them together. There isn't in this case. 2 bromine plus 2FeI3. What's the rule? Again, take the bigger number, multiply by the smaller number. So you get 6 bromine. There's no other element here. This is just bromine by itself. This is a compound. So you're going to multiply the big number in front by this subscript here. There's a hidden 1. And this subscript here is a 3. So you get 2 times 1, 2Fe. 2 times 3, 6 iodine. Three. This is harder. I'm going to make it a little harder in a minute here. Let's do this first. I'm going to add to this after we go through it. Okay, so there's a 1 in front. It's not shown, but it's there. 1 times 1 is 1 lead. Okay, here's the harder part. 1, take this 1, multiply by this 2. You get what? 2 of whatever's inside the brackets. So you get 2, I'm not done though, 2 of the NO4. Now, if you go back to the question, it says, list the total number of each atom. We have to go further in this. I'm just telling you how many of the nitrate I have. I've got 2 of the nitrate, but each nitrate has 1 nitrogen. So multiply the 2 by the 1, you get 2 nitrogen, and then multiply the 2 by the 4, because it also has 4 oxygen, you get 8. And bring this down. That's your answer for the first compound. I'll just make this bigger here. So it doesn't look like 80. Well, Okay, this one's easy. 2 sodium, 2 iodine. So when they say the total number of each type means for each element. You have to separate each element. Okay, let's try this. This is, I think in general, when you're doing any sort of homework or even, I would say not necessarily assignment, but homework, because you know I'm going to go over the homework for sure. Make sure there's extra space right here, right? So I can go over stuff. I can add to it. So I'm going to change this problem. Let's see if you can do this. It's the same compound. It's lead 2 nitrate. But now there's a 3 in front. I'm going to keep, I'll change it. This is easy though. Change it to a 6. Does that make sense? It's a 1 to 3. So yeah, double it. Okay, try that out. See if you can do that. Total number of each type of atom. Separate the elements. Yeah. What do you think? How many lead? Good. 3 lead. Now let's do this one step at a time. How many nitrate? This is nitrate here. 3 times, yeah, so 6 nitrate. We're not done though. We have to go further. We now have to take this number and multiply it by the subscripts. So 6 times 1 is 6 nitrogen. 6 times 4 is 24 oxygen. And then the rest is pretty easy. Does that make sense? Okay. 4. I bet some of you haven't done 4. I'm not going to ask who. I don't want to embarrass you. I'll give you 2 minutes to try 4 out. If you've done 4, you're awesome. Not that you're not awesome if you haven't, but that's good. If you've done 4, read ahead. I'm going to go over this next, page 208, 209. Read ahead. I'll finish 4 in a minute, but I just want to give the others a chance who maybe we're struggling to finish it now that we've gone over 3. 3 will help you with 4. Who's going on the tree planting thing tomorrow? Anyone here? What? I know. You didn't give him out in time. He didn't even tell me what time I have to be here. I text him. He doesn't give me information. And he's on the retreat, skipping another day of school. Not that I'm one to judge because I went on the grade A retreat. What do you guys think of the grade 8s? Good? No? You don't like the grade 8s?
I feel like I can't slow them. That was us 2 years ago. So
What was that?
I feel like I can't make fun of them too much. That was us 2 years ago.
Exactly. See?
But when I'm in grade 12, I'll make fun of grade 8.
There you go.
It would be 5 years ago.
My school, they did some bad things to at grade 8. Push them into the lockers. Yeah, you guys are nicer. I like the grade 8s. The grade 8s are good. Not bad. Good class. Okay. Now, let's go over this. 4. Backtrack to 4, and then I'll start the new stuff, balancing. Okay, 2K. We need this. What we're doing now, we need this to balance the equation. Plus 3 NH 4 2 SO4. Okay, I'm gonna. Okay, 2 times 3. I'm gonna go through again. Multiply the bigger number, the coefficient, by the subscripts. If there's no subscript, that means there's 1 there. 2 times 3 is, whoa, that's pretty big. 2 times 3 is 6. 6K, 6 potassium. 2 times 1 is 1 phosphorus. You got to be explicit. You got to put the 1 there, even though it's not shown as a subscript. 2 times 4 is 8. Whoa. 8 oxygen. Put a line between. 3 times 2, we're not done here. 6 ammonium. We'll come back to this. 3 times 1 is 3 sulfur. 3 times 4 is 12 oxygen. Wow. So go to this. There's 6 of these, which means there's 6 nitrogen and 24 hydrogen. Everything else remains the same. 1 sec. 3 sulfur, 12 oxygen. I'm not done yet, though. I don't like writing this big red. That didn't help me. Let me just see here. 8, 24, 3 sulfur, 12 oxygen. Now, notice something. We have 8 oxygen here, 12 oxygen here. We have to add them together for a total of 20. Don't forget to do that. Got a question? PO4 is a polyatomic. Yeah, you could write 2 PO4 if you want. This should be 2, by the way. You could write, I know what you're thinking, Ray. You could just write 2 PO4 and then multiply through. You could do that as well. I kind of skipped that step to went all the way through. Okay. So that's what we need. This is basically just counting atoms. We need to do that for what's coming next, which is balancing equations. This is balancing equations. Yeah, definitely. This is notes. I'm going to start off with the example on page 209. So I've got what we're trying to do. I'm going to write down a chemical equation. Leave space in front of the elements and compounds. Okay, so why did I put space or leave space in here? Because there may be a coefficient that goes in front. To do what? To balance the number of atoms. We want the same number of atoms for each element on both sides. So let's write that down. Same, this is what we want. Same number. It's not a hashtag, it means number. Same number of atoms for each element or each type. on both sides of the equation. Okay. So I'm just going to bring this down here again. Start fresh. Let's do a count. Now here's what I suggest you do. You can do it however you want, but this is the suggested way. I write a line down close to the middle. Yeah. Okay, so this column here represents the left side. You can put reactants if you want, like R for reactants, P for products. Product side. Okay. In this column here, I list all the elements are polyatomic ions. I list. You don't have to write this in, but I'll write it in to make it clear this first time. I'll probably leave it blank from here on in, but elements / polyatomics. So what do I mean? I do that there. Yeah, what I mean by that. I put Fe here. Where do I get that? You can look at either side. It's going to be the same. I look at the left side. It's easier. That's my first element. So that's why I wrote it down. That's my second element here. I'll write it down after that. That's all there is. Just look. You only need to look at the left side to get everything that's there. It's the same on the right. It's just combined on the right. Okay, so what are you doing under this column here? The reactant side. You're counting atoms. How many Fe? 1. Okay. How many bromine? Covered it up, but it's 2. Do the same thing on the right. It should be equal. If it's not, we got to fix it. How many Fe on the right? 1. How many bromine on the right? 3. It is not balanced because all numbers on the left side for each element have to be balanced. This is balanced. This is not. So we play around with it until it is. What do I mean by playing around with it? We can only, this is the rule. I'm going to repeat it, memorize it. You can only change the number in front. That's the rule. There's a reason for that. If you change, you cannot change this number. That stays as is. That stays as is. Why? Because if you change these subscripts, it's like changing the ingredients in a recipe book. Now you can add more flour, take away a little flour, add more water, remove a little water when you're baking bread. But if you want to make a specific type of bread, you got to stick with that specific flour. So changing these numbers here is like changing it from flour to, I don't know, changing it from, let's say, durum wheat to some other unknown ancient wheat. Now what are you gonna do? You're gonna get a different type of bread. You can't change those subscripts. If you change the subscript, you're changing the compound. So that's the rule. You can only change these numbers here. Erase it and highlight it again. You can only change these numbers in front, the coefficients. That's it. And it's a guessing game. It's a guessing game. Now, there are some general rules. You can read that on page 209. You can come back to that later, but I'll give you some of the rules as we go through it. Okay, so as a general rule, if you've got a compound and there's no other compounds, see if you can play with that first. So what do I want? I want it so there's equal amounts of bromine. I have 2 bromine here, 3 here. as a general rule, find the smallest number that these two numbers go into. 2 and 3 go into 6. So what do I have to multiply the 3 by to get 6? 2. Oops. 2. Okay. See if that works. What do I have to? And we'll come back to this in a second here. We'll change that in a second. Let's see what we get when we put the coefficient or change the coefficient to 2. Let's see what we get. Let's add up numbers, or add up the number of atoms again, because now everything's changed. We have on the right, we now have 2 times 1, 2Fe. That changes. 2 times 3, which is what we wanted, 6. A little messy, but 6. Okay, these numbers haven't changed yet. Can I change them? Of course I can. I can put a 3 in front of here. That gives me 6, which is what I want. Am I done? Good. I have to change the iron. Yeah. So put a 2 in front. Now you're done. Just go through row by row. These numbers should be equal. These should be equal. Are they? Yes. Check. These should be equal. Are they? Good. Check. You're done. Balanced. You don't have to write this. I'm writing it for your sake. Okay. Harder one. Let's try this. Oops. It's an NO2. Okay. You don't have to put these numbers in front. I'll add them for now, but you don't need them. Just make sure there's space. Okay, let's make up our table here. I would put a line down somewhere near the center. Line across. You can put reactants, products here. This will be, I'll write this one more time, but I'm going to leave this out in the future. Elements, individual elements / polyatomics. If there's any polyatomics, you can write down the polyatomics. Okay, here's the rule. Take a look at this. This is why I told you it's important to know the polyatomics. That's a nitrite. That's a polyatomic. You have to check to see whether it's on the right side or not. It is. There it is. So if there's a polyatomic on the left, it has to be on the right. Are there any other polyatomics? Yes, there it is there. It too has to be on the right. And it is. It's right here. To do what? To list it as a polyatomic. Well, I'll show you what I mean by that. Let's go through. There's tin, SN. Now, we come to this. I can break it up into individual elements, into nitrogen, oxygen. That will still work. The quicker way is write it as a polyatomic. When? When it's on the right side as well. When each of the polyatomics is on the right. They all have to be on the right. Otherwise, you can't do this. It just makes it easier. Next one, K. Next one, PO4. Why can I write this? Because it's on the right. It's there on the right. Just going to erase some of these just to make it more clear. Okay. Let's see. Don't tell me. Let's see if you can do it. Give it a try. It's hard without me telling you exactly. Let's see if you can do it. Give it a try. You know what I'm referring to, right? I'm getting this from, it's in your handout. If you want to pull that up on the other tab. Your, what is it, the 4.3 handout? I posted online. Okay, so 10. 1 on the reactant side. Whoa. How many on the product side? 3. To start with, we can change these later by putting a coefficient in front, but to start with, this is a nitrite. 4 on the left. How many on the right? Yeah, there's no brackets. See that? No brackets means 1. Potassium on the left. How many? Good. Ow. On the right? Very good. Is it balanced? No, not yet. Okay. I would try balancing these polyatomics. This is a guessing game. You can't always get it right the first time. That's why I suggest you do this in pencil. So try balancing that first. There's 4 on the left. Let's make it so there's 4 on the right. Put a 4 in front. But by doing that, what does this 4 do? Well, yes, it changed. This was originally 1. There's no brackets, so that means when you multiply it by 4, you get 4 of them. So now it's correct. However, remember this 4 multiplies with the potassium as well. So there's 4 potassium. That screws things up. It doesn't work. So far, not working. Okay, backtrack. This is going to happen. That's not the approach. I can tell right away. And then potassium on the right is 1. Phosphate, I forgot to put it down. There's 1 here, 4 here. Okay, let's try balancing the potassium. How do I know to do that? Just because I got more experience. Making a guess. You're going to need to do this in pencil. This table should be written out in pencil, especially these numbers here. Okay, there's 3 potassium on the left. Let's try 3 on the right. Put a 3 in front. Is that going to work? No, that's not going to work either. Okay, I can tell just by looking at it. That won't work. Okay, let's try this. Try balancing the tin. There's 3 on the right. There's only 1 on the left. That should work. We're going to make it so there's 3 on the left. Put a 3 in front. The 3 multiplies with the 1 here to give 3 tin. It also multiplies with the 4. The 4 nitrite. To give what? To give 12 nitrite. Now we can change. Go back over here. I only have 1 nitrite on the right. 1 of these. How do I make it so there's 12? Put a 12 in front. That changes everything to the right of it, not just the nitrite. We can put that down as 12, so that's correct now. That's now balanced. So far, that works. But it also affects the potassium. There's now 12 potassium. But there's 3 on the left. How do I make it so there's 12 on the left? Yeah, good. Put a 4 in front. That gives me now, I'm going to erase this because I'm running out of room here. That gives me 12 potassium on the left. Okay. Does it affect anything else? The 4 multiplies with the 3 to give 12. But remember, the coefficient multiplies with everything to the right of it. So that includes the PO4. There's only 1 to begin with. You multiply by 4, you get 4. We're now balanced. You can see that's going to take some guessing. So again, use pencil. And it's okay to make mistakes because it's somewhat random. Trial and error. Let's do the last one. Example 3. Yeah, I'll do that. That's right. Let's do this one. C2H6 ethane plus O2 produces, whenever you have a reaction like this, when you see something that looks like this, carbon and hydrogen, that's an organic molecule, ethane. Organic means it's made up of carbon and hydrogen, sometimes oxygen. It's an organic compound. Whenever you have an organic compound reacting with oxygen, your products are always CO2 and water. Doesn't matter the order. I was just looking to see what order it is. Doesn't matter. You can put the water first if you want. Those are always the products. Called a combustion reaction. Okay. When what? When you have a hydrocarbon, something made up of carbon and hydrogen, plus oxygen, it always gives you carbon dioxide plus water. And it's called a combustion reaction because it's reacting with oxygen. Okay, do the same thing. Your 3 columns. I'm just going to put reactants and products here. Forget about, the first column. In this case, it's going to be all elements. Carbon, hydrogen, oxygen. List the elements. There's no polyatomics. List the number. 2 carbon here. On the right, 1. List the hydrogen here. 6. Whoops. 6 on the left, 2 on the right. List the oxygen. Here's the trick. 2 on the left, 2 on the right here, plus another one here for 3. See if you can balance it. I'll help you in a second. Don't tell me, but let's see if you can do it. Here's the trick, by the way. Save the oxygen till last. If you have a single element, balance that last, especially if it's oxygen. That's one trick that works. I usually try to balance the carbon first. Don't forget to add up all the oxygen. Okay, let's try carbon first. There's 2 here. I want 2 here. Put a 2 in front. Kind of messy, but that's my 2. What does that do? That gives me on the right 2 carbon. However, this 2 not only multiplies with the carbon, but also the oxygen to give me 4 oxygen plus this one here. There's now 2 times 2. There's 2 times 2 is 4 plus 1, 5. Not 3 anymore, but 5. Okay, what about the hydrogen? I've got 6 on the left, I want 6 on the right, put a 3 in front. 3 times 2 is 6. However, that changes the oxygen. I now have 3 times 1, 3 oxygen, plus the 4 from here. 3 plus 4 is 7. Almost done. It's getting messy. Okay, so far let's do a checklist. 2 carbon, check. 6 and 6 hydrogen, check. This is not balanced. I got to put a number in front here. What multiplies with 2 to give 7? Before you say anything about 14 or etc., but what number multiplies with 2 to give 7? Half of 7 is? Yeah. So here's the thing. This is now mathematically correct. Okay, this now gives me 3.5 times 2 is 7. However, the problem is you can't have 3.5 molecules in chemistry. You can only have whole numbers. So the trick is this. We're almost done. This would be like part marks if you got to this point. To finish it, you don't have to put brackets around it, but I'm going to treat it like it's a math equation. Pretend there's brackets around it and multiply it by 2. What does that mean? That means multiply each coefficient by 2. So you get what? Yeah, watch. I'll duplicate it. Put down here. Erase a couple things to make it more neat. I don't need lines in front, okay? So what do I have? Multiply each number here by 2. So down here, I'll just write the correct form. I'll write this out, that out, put the new numbers in. The new numbers are 2 times, there's 1 in here. It's not shown, but there's a 1. 2 times 1 is 2. 2 times 3.5. Here's the one we had to fix, is 7. That's a whole number. Now it's correct. 2 times 2 here is 4. 2 times 3 here is 6. You're now done. So the trick again is yes, you can use half numbers, but just make sure you multiply everything by 2 after that to get whole numbers. Can't have a half a molecule. That's what 3.5 means. It means 3.5 molecules. There is no half a molecule in chemistry. What is this? What's this left side here? It's a recipe. That's all it is. That's all cooking is. Cooking is just chemistry, right? You have to have the proper amounts. If grandma doesn't use proper amount, which grandma always uses proper amounts, we don't. That's why grandma's cooking is perfect. She uses the proper amount. She uses the proper amount of heat. She stirs it to make sure the chemical reaction takes place. She doesn't know it's a chemical reaction, but it is. So putting the proper numbers in front is making sure that you abide by grandma's recipe perfectly. Right? 3 parts flour, 1 part water, and a pinch of salt. To get what? To get the proper products, and you get those exact numbers. Those will just flow out as a result. Okay, so on page, that looks a little messy, doesn't it? Page 211. Let's write that down. Page 211. You got that in the handout that I posted last day. Go back to the latest handout. I don't know what. Let me see. Where is that? It's October 18th. Go back to that handout. Go to page 211. Give that a try. There's a lot there. So I'm giving you, what is it, 12 minutes in class? You can get started on it. Do all of that. See what you can get done. It's just homework, not an assignment. I'll give you lots of practice before I give you the assignment. So we'll go over this next day. We don't have a class Friday, right? So Monday. But